lesson 7, we're going to look at one-to-one and onto functions. So one-to-one is when we have a function where for each independent variable, there's exactly one dependent variable, and for each dependent variable, there's exactly one independent variable. So basically, let's look at these examples here to help you understand what that definition is really saying. So if you look at this first example, see how 1 is going to exactly one element in B, and A has exactly one thing coming from it, and 2 goes to exactly one thing, and E only has one thing coming to it. So basically each one of these elements is only going to one thing, which makes it a function. But then over on this side, each dependent variable only has one independent variable coming from it. So it's called one-to-one because each thing is going to exactly one thing. So this one is an example of a one-to-one function. But if you look over here, see how A has two things coming to it? So yes, it's a function because each input is only going to one output, but your dependent variables are your outputs. In this one here, there's two things coming to A, or two inputs that map to A. So this one's not one-to-one. So when a function is called one-to-one, it's also called an injective function. So one-to-one functions are also called injective. Typically, you're going to see this as one-to-one though, but the other name is injective functions. And sometimes you'll see, instead of one-to-one like this, you might just see it as 1-1. So these are other notations for one-to-one. And then the other type of functions that we're going to look at are called onto functions. So basically for onto functions, for each dependent variable, there is a corresponding independent variable. So basically what that means is all dependent variables are being used. So if you look, see how in set B are my outputs, my dependent variables, D does not have anything going to it. So D is not being used. So that means that this is not onto. So there's no input that'll map to D. Now when you look over here, this would be onto because each dependent variable is being mapped to. So each of these is being used. And now even if I draw in, let's say I take this 3 and I map it to C, this is still onto because I still have all three of these things having something getting mapped to it. However, in this case, this would not be a one-to-one function because C has two things coming to it, but it is onto. So onto functions are called surjective functions, is the other name for them. And the last thing is, well, what happens if a function is onto and one-to-one? Then it's called bijective. So a bijective function is when it's one-to-one and onto. So let's look at some more examples with just identifying if a function's one-to-one, onto, bijective, or neither. So on this page, we have some different examples, and we want to identify if the functions are one-to-one, onto, bijective, or neither. So first thing you want to do is you always want to check are these functions, but it does say the following functions. So that means each input's going to one output. So now we have to look at, first of all, is it one-to-one? So if you scan your outputs, each of these outputs only has one input going to them, and each input is only going to one output. So we know that it's one-to-one. And then to decide onto, you just have to look at the dependent variables or the outputs, and everything's being used. Everything has something being mapped to it. So it's onto as well. So basically that means it's bijective. So it's both. If we look at this one, it's one-to-one because everything has something being mapped to it, and it's only one thing gets mapped. So one input gets mapped to one output only has one input coming to it. So this one's 1 to 1, but it's not onto because C doesn't have anything coming to it. So this is not onto. So we would just call it a 1 to 1 function. This next example here would not be 1 to 1 because B has two inputs coming to it. So this is not 1 to 1. But it is onto because everything in the outputs is being used or has something coming to it. So it's onto. And then this one is not 1 to 1 because of this element B. B has two things coming to it. And it's not onto because D has nothing getting mapped to, or nothing is not coming from anything. There's no input that would ever get you D. So that's why it's not onto. So in this case, this would be neither. And the last few examples here. So in this one, we have, again, it can't be onto because this element here has no way of being an output. There's no input to get this output. And it can't be 1 to 1 because this element here has two things mapping to it. So again, this one's a neither case. This example here can't be onto because this element will never get mapped to. And all of these only have one input getting these outputs, so it would be 1 to 1. This one would be onto, but it would not be 1 to 1 because here we have two arrows coming to one element. So since we have two things getting mapped to one thing, it can't be 1 to 1, but it is onto because every B value, or every element in B is being used. So this one's onto. And then this one, you have it's onto and it's 1 to 1. Onto because everything over here is being used. 1 to 1 because each of these elements only has one arrow coming to it. So this is going to be both, which means bijective. So then the next example here, we're going to take a look at, well, what does this look like on a graph? So functions on a graph, how do we determine if they're onto, 1 to 1, both, or neither? So here we have this function f of x equals 3x minus 4, so it's just an equation of a line. And if you notice this notation here, so let's talk about that for a minute. So this symbol, whenever you see this, means the real numbers. So basically any number you can think of other than imaginary numbers. So what this is saying is this function f is defined on the real numbers to the real numbers. So the inputs are all of the real numbers, and the outputs are all of the real numbers. So these are like the x values can be any real number, and the y values can be any real number. So it's asking you, is it 1 to 1 onto both or neither on this real numbers to real numbers mapping? So if you look at this, basically you have to ask yourself, so if we're trying to decide onto, so let's start with that. We have to ask yourself, is it onto? So basically, is every dependent variable or every y value being used? So when you scroll up and down this, remember this is a line, so it's going to go on forever. If you think about the range of this function, the range is going to be negative infinity to positive infinity, which means all real numbers are going to be used. So all y values are going to be used. So yes, it's going to be onto because every y value is going to be used. It's going to have something going to it. So every single y value, if you move up and down the y-axis, is going to be used at some point. So that means it's onto. So then the next thing is we have to decide, well, is it 1 to 1? So yes, it's onto. So 1 to 1 means that for each x value, there's only one y value, and for each y value, there's only one x value. So if you look, each x value is going to have only one y value. For every single x value, there can only be one y value. And then for each y value, so as I move along the y values, there's only one x value. So that means it is 1 to 1 because each x value has exactly one y value, and each y value has exactly one x value. So this is true. So that means that this function would be both one-to-one and onto on this real number to real number mapping. So it would be called bijective, or you could just say that it has both. So I'm going to just answer it as both because that's what the question asks. So let's look at another example like this. So for this one, we want to know, is this function g of x, remember this function g of x has arrows up here, if it's onto one-to-one, both or neither on this real number to real number mapping. So the first thing you have to decide, so is it onto? So that means, are all of the y values being used? So as you move up and down the y-axis, are all of the y values being used? And the answer is no, they're not, because if you look here, -6 is never going to be used. -8 is never going to be used. And that's because the range of this function, so if you look at the range starts at -2 and it goes up to positive infinity. So since the range is in all real numbers, so these are like the x values and these are the y values, all of the y values aren't used because the range is in all real numbers. The range is -2 to infinity. So only -2 all the way up to positive infinity are going to be used. So this is not onto because not all of the y values are being used. So then we have to decide, is it one-to-one? So for each x value, do we only have one y value? And for each y value, do we only have one x value? So if you look along the x-axis, for every x value, you're only going to have one y value. There's only one y value being used. So that part's true. But when you move up and down the y-axis, let's say at y equals 6, I actually have two x values. I have an x value here and I have an x value here. So that tells me that this cannot be one-to-one because I have two x values that have the same y value. Or for each y value, there's multiple x values. So this is not one-to-one because most of the y values are being used by two x values. So since this parabola is symmetric, most of these y values have two x values associated with them. The only one that wouldn't would be the vertex. So this is going to be neither. So now the question asks, well, what happens if we take this function and we only look at it from the real numbers to -2 to infinity? So now what if we restrict, so the x's are going to stay -infinity to positive infinity, but the y values that we're looking at is only going to be from -2 to infinity. So basically what it's saying is cut this bottom part of the graph off and now only focus on this section of the graph. So if we only focus on this section of the graph, would this function be onto or one-to-one? Does it make any difference? So it's asking us to decide, is it onto now? So yes, it is onto, because if you're only looking at this section of the graph, that means you're starting your y values here. And what it's asking you is, are all of your y values being used from -2 to infinity? And yes, they are, because -2 is the lowest value in the range. And all the way up to infinity, all of these y values are going to continue to be used. So yes, it now is onto, because all y values are are used over this interval from -2 to infinity. Now, keep in mind that this does not necessarily mean it's on or 1-to-1. So if you look, it's still not going to be 1-to-1 because it's not going to change the fact that you have two of the same y values for two different x values. So if you look, this picture still includes all of these points where I have multiple x values with the same y value. So in this case, I have two x values, I have 4 as a y value. So it's still not 1-to-1 though. So I'm just going to write that, not 1-to-1. So that won't change that. So let's look at just a couple more of these and then that'll be it. So example 4, we're going to just do the same thing, looking at this function on a graph. Is it onto, 1-to-1, both, or neither, from the real numbers to the real numbers? So onto means that all y values are being used. So if you look, this graph doesn't have any restrictions. The range of this function is going to be -infinity to +infinity. So as long as the range matches this mapping, the y values that you can map to, that means it's going to be onto, because that means you're going to be able to get out all of the y values that you need to in order for this to work. So it's going to be onto. All y values are used. And then 1-to-1 is also going to be true here. This function is 1-to-1 because if you look, for each x value, there's only one y value, and for each y value, there's only one x value. So it is 1-to-1 because every x value has exactly one y value, and each y value has exactly one x value. So this function would be both, or bijective, because it's onto and 1-to-1. So last example, we have this absolute value function, x minus 2. So here's a graph of that. Keep in mind this is going to keep on going in both directions. First thing we want to do is we want to take a look at this on the real going to reals is our mapping for our function. So these are our x's that we're looking at. Here's our y's that we're looking at. So when we look at this entire picture, is this onto? Well, no, it's not onto, because if you're looking at this entire picture, -infinity to +infinity for x's and the same for y's, we'll never get any of these y values down here. So it's not onto because there's several y values that'll never get mapped to. And it's also not 1-to-1 because if you look at, let's say, 4, when y equals 4, there's two x values that have the same y value. So this one's neither. Basically the same reason as example 3. So if you just look at example 3, it's the exact same scenario. Instead of it being a U shape, it's a V shape is the only difference. And then what they did now is they restricted this. So they said, well, now let's just take a look at this picture from -infinity to +infinity for the x values. But then for the y values, let's just focus in on this top half of the graph. So if I'm only focusing in on this section of the graph, is it now onto? So yes, it is now onto because each x value or each y value is being used. You're going to always have every y value from 0 to infinity. So this is now onto, but the question asks us, is it 1-to-1? So does that change the fact that you have x values that have, or you have y values that come from two different x values? So it does not. So this is still not 1-to-1 because if you look, 6 has multiple x values, 4 has multiple x values. Any of these points, because this picture is going to be symmetric, any of these y values are going to have two different x values. So this is still not one-to-one, even though I just restricted where I'm looking for the y values. So this is not one-to-one. And then one last thing I want you to add on is, in order to determine if something's one-to-one, instead of having to think of it as go up and say, okay, well, 6 is the same y value and there's two different x values, basically what you can do, if you notice, if I draw a horizontal line through, my graph hit, or my line hit the graph twice. So that's another way. If you ever draw a horizontal line and it hits your graph twice, that means your function is not one-to-one, because that means that there's two x values that have the same y value. So this is called the horizontal line test. If you remember, the vertical line test is to determine if you have a function. The horizontal line test is used to determine if a function is one-to-one. So basically, we were using the horizontal line test all along when we looked to say, okay, well, there's two 6's that came from two different x values. We did the horizontal line test, we just didn't draw the horizontal line. So the shortcut is to just imagine drawing this horizontal line through. So the horizontal line test says that if any horizontal line can be drawn without crossing the graph of the function in two or more places, then the function is one-to-one. So if it passes the horizontal line test, it's one-to-one. If it passes the vertical line test, that makes it a function. So in order to say it's a one-to-one function, it has to pass both horizontal and vertical line tests. And onto, there's not a test for. It's really just imagine looking at the range, and if the range matches what you're looking at for your mapping, for what the graph can be mapped to, if they match, then it is going to be one-to-one. Or you just move up and down your y-axis and make sure that all of the y values are being used.